Good morning, my dear friends. See now, today we will begin with some of the problems in which you are going to see how exactly we are going to draw the stress distribution diagram by using stress concept and strength concept and by load balancing concept. Okay, so I will start with the first problem. Okay, I will read the problem. A simply supported PSC beam of rectangular section, okay, 300 mm by 500 mm is loaded with a UDL of 40 kilonewton over a span of 6.25 meter. Sketch the distribution of stresses at midspan if the pre-stressing force is 375 kilonewton is applied when the tendon is eccentric 20 centimeter above the bottom fibers. Solve both by stress concept and by the principle of internal resisting couple, or it is strength concept. See now, what he has given is now, we shall begin with the solution now. So here he has given a PSC beam in which he has applied a load of 40 kilonewton or 40,000 newton, okay, and the cable is placed at in sense now he has placed this cable at 20 centimeter above the bottom, in the sense 200 mm above the bottom he has kept. So now cross sectional area of this beam is now 300 mm by 500 mm. So I can call this as YT, topmost fiber, it is 250, and bottommost fiber YB is now 250. Okay, I think these two you can easily write because this entire depth is now 500 mm. So from the neutral axis, YT is 250. In sense, YT means it is top fiber's distance. Okay, YB means it is the bottom fiber distance. Okay, 250, 250, both. Okay, so now since now the cable is laid at 200 mm from the bottom, okay, I can say that eccentricity becomes 50 mm because this is 250. Am I right now? Since this is 250, so automatically this eccentricity becomes 50 mm. So now I think now he has given the pressing force F as 375 kilonewton, or it is 37500 newtons. Eccentricity is minus 50. See now, anything below CGC, this is your CGC line, okay, this is your CGC line, this is your CGS. CGS means it is a CG of steel, CGC means it is a CG of concrete. Okay, from CGC, whichever is below, I will assign them negative sign. From CGC, whichever is above, I will assign positive sign. Okay, see now, so since eccentricity is below CGC, so I am assigning a negative sign for it. Okay, E is now minus 50 mm. So now also area can be now easily calculated. It is 300 mm by 500 mm, so it is 15,000 mm square. And also since it is a rectangular section, the moment of inertia can be now easily calculated. It is 3 BD cube by 12. Okay, 300 into 500 cube divided by 12. It will give me this much. Okay, so then YT, as I have said, it is 250 mm, and YB is also now 250 mm. So now we will try to calculate bending moment at the midspan section. In a sense, bending moment at midspan I want, because he has asked you to calculate the stresses at the midspan. So I will try to calculate the bending moment M. Okay, so he has given you this 40,000 Newton is your total load. It is not the UDL per meter. Okay, it is a total UDL. So it is WL by 8. It is now. It is not WL square by 8. Okay, it is a WL by 8. W is now 40 into 1000. Okay, span is 6.25 span. Okay, divided by 8. Okay, will give me 31250 Newton meter, or it is 3125000 Newton mm. Okay, see now to find out the stresses by using your stress concept. Okay, so I want to now find out this stress at the top fiber FT. Okay, FT means it is given by Baba. Stress concept says that it is F by A plus or minus FEYT by I plus or minus MYT by I. This is the equation, okay? Because I want to find out the stresses at the topmost fiber, Ft. Wherever Ft is there, I have to put Yt and Yt, okay? So fill the values now. F value I know, area I know, again F is known, eccentricity is now minus 50 because eccentricity is below CGC. Yt is now plus 250 because Yt, as you know, it is above CGC. It is above CGC. Is it right or not now? Since it is above CGC, okay, I am going to assign plus sign to it now. Okay, plus sign to it. Divided by I is, I value also I know, plus or minus m is m, okay? Yt again it is now plus 250 divided by I value I know. So now this works out to be 2.5, this works out to be minus 1.49, this works out to be plus 2.5. So if you add them algebraically, I will get plus 3.51 Newton per mm square. Okay, so this is the top fiber stress Ft. Similarly, you can find out the stress at the bottom fiber, Fb. Fb, now you can write it as now F by A plus or minus FeYb by I plus or minus MYb by I. Am I right? So all the values you can put. The only change is now eccentricity is minus 50 and Yb is now minus 250 because Yb is below CGC. Below CGC, whatever is there, I am assigning negative sign to it. Okay, so MYb by I is now, FeYb by I. So Yb is now minus 250. I is, you know the value. Again, M value I know. Again, Yb is now minus 250. Okay, divided by I. So now again you will get these values, add them algebraically. So you will get plus 1.49. But by here plus sign indicates that it is compression. Here also plus 3.51 indicates that it is compression. Okay, so now top fiber stress is plus 3.51, it is compression, and bottom fiber stress is plus 1.49, it is also compression. So now if at all I want to draw the stress distribution diagram, you can see here now. Okay, see now top fiber stress is 2.5, F by A term is 2.5, it is plus 2.5. Fb is also now plus 2.5. So here also it is now plus 2.5, here also it is 2.5. So I can draw this stress distribution diagram. Plus next term is Feyt by I and Feyb by I. Feyt by I term is minus 1.49 and Feyb by I term is plus 1.49. So here it is now minus 1.49 and here it is now plus 1.49. So you can draw the stress distribution diagram. Okay, and last term is Myt by I. Its value is now plus 2.5. Okay, plus 2.5, and this bottom fiber stress is Myb by I. Its value is now minus 2.5. Okay, so if you add them algebraically, you will get the values as top fiber stress as 3.51 plus and bottom fiber stress as plus 1.49. So you will get 3.51 as the top fiber stress and bottom fiber stress is 1.45. This is the resultant stress distribution diagram. Okay, this is how you can solve the problem by using stress concept. Okay, now we shall see the same problem by using now the strength concept. Okay, how to find out the stresses by using strength concept. Okay, so now in the strength concept, you know that F is equal to C. Am I right now? So F value you know that it is 375000. So it's equal to C now. So this much Newton. So now lever arm is given by A is equal to M by C. Am I right now? In our strength concept, you know that lever arm A is given by M by C. So M I know and C value I know. So it will give me lever arm A as 83.33 mm. Am I right now? Lever arm is now 83.33 mm. So if you just also you know that eccentricity is now 50 mm. Okay, therefore H can be calculated. If you just go to your strength concept, H can be calculated as A minus E. I have already said you. So A value I know 83.33, just now I have, and E value I know. So it will give me this much as H value. Okay. So now, so top fiber stress, if at all I want to find out, it is a C by A plus or minus CHYT by I. Okay, by your strength concept. So C I know, area I know, again C I know, H just now we have found out, YT is now plus 250 divided by I. Okay, so you will get resultant stress as plus 3.50 Newton per mm square, and plus sign indicates that it is compression. Okay, similarly, bottom fiber stress FB can be written as C by A plus or minus CHYB by I. Okay, all the values you can put it here now. C value you know, A value you know. Okay, again C value you know, H you have calculated, and your YB is now minus 250 because it is below CGC. I is this much. Okay, so you will get the value as now plus 1.51. Okay, so you can draw the stress distribution diagram. FT is plus 3.5, plus 3.5 is FT, and FB is 1.51 plus 1.51 plus. Stress distribution diagram is like this. So now this is exactly what we have obtained the answer from stress concept. So now whether you calculate the stresses by using strength concept or by stress concept, you will get the same answers. Okay, thank you very much. Thank you.